Let's see if it's recording. All right, now. Again, welcome to Data Science and why it matters today. So, in this workshop, you'll learn the importance of data in today's world, data science for decision making, the future of data science, and this will be hosted by Mr. Jude Valiente. He is an automation engineer and an associate IT analyst. All right, so I invite you guys to join our Discord channel. So, it's a students networking community. Hashtag self-study, hashtag professional development, and hashtag job seekers. Scan the code and join our Discord channel. So we have a server there, our Discord server instead. All right, now, a few reminders. The more you learn, the more you earn. So I hope you have your notes by your side. Please mute your microphones and prepare your questions because there will be a Q&A portion towards the end. So without further ado, let me introduce to you our host for today's workshop. His name is Jude Ryan Valiente. He's from the Philippines, same as me. He's an automation engineer. He graduated from Ateneo de Manila University, currently working at Data Analytics Ventures Incorporated here in the Philippines. So, guys, let us all welcome, virtual clap, our host for today, Mr. Jude Ryan Valiente. Hi, Jude.
Hello, everyone. I hope everyone's doing good. So let me just thanks for sharing an introduction about me, Aldrich. And I'm just sharing my screen and let me know once it's visible on your end. So probably type 3 in chat if you can hear me and see the screen as well. All right, thanks, Aldrich. I assume the same would be for the rest. Okay. All right, cool. So let's start with the workshop. I'll first share what the agenda is for today. So as Aldrich mentioned earlier, there are three main key points that we will be discussing. The first one is data in today's world and why it is important. The second one is data science and how it affects decision making in organizations. And lastly, what the future is for data science and what are the possibilities in case you want to pursue a career in data science. So a little background about myself before I start. I'm currently an automation engineer for Data Analytics Ventures Inc. I am also a professional Scrum Master. So my work experience spans with four different companies now. So I work with three multinational companies and one for a conglomerate here in the Philippines. So my experience started in Accenture, where I worked as a data analyst and business intelligence resource. So I moved to Philip Morris International to work in IT operation systems. Then I moved to Procter and Gamble as an IT manager. And again, now I work as an automation engineer in Data Analytics Ventures Inc. So some of my interests and hobbies are listed here. So I like listening to podcasts. I read books. I do gaming and I like physical activities and also music. All right. So let's start with what is data. Let's define what data is. Okay. So according to Merriam-Webster .com, so data is the factual information such as measurements or statistics used as a basis for reasoning, discussion, or calculation. Now, information output by sensing device rather, or an organ that includes both useful and irrelevant or redundant information and must be processed to be meaningful. So, in a nutshell, data is something that we can use. It is an information tool that uses that we must rather process in order for it to become meaningful. So let's take a look at examples if these are data indeed. All right. So let's take a look at this one. So there are six apples in this picture. So just think about it in your head. If this is data, what about this one? So we have apples and bananas, right? Next is we have a table. So this indicates the athletes that competed in the Olympics since the first iteration of the Olympics. We have here the sex, age, height, what team or country they played in, which season they played for, the city that the Olympics was held in, and even the sport and the event and the medal. So just think to yourselves, is this data as well? How about this one? Video, a video format. So let's say a Joe Rogan experience video conversation with Elon Musk. And even something to the right here, an audio signal, or like let's say a conversation even, is this data. Now, what about customer reviews in Amazon? Are these data as well? So for example, customer reviews for the iPhone 14, and then you can see here the top positive reviews and the top critical reviews. Are these data? And the answer is yes. So again, let's go back to the definition of data. As long as it is a factual information that measures something or describes something even, that can be used for reasoning, discussion, or calculation, and can be processed even though it is irrelevant or redundant at times. However, it should be useful, and it must be processed to become meaningful. All right. So in a technical sense, we're generally looking at three types of data actually. So the first is unstructured data. So unstructured data basically means that it's not organized in a manner for analysis just yet. So again, I mentioned earlier that data can come in different forms, be that in video, in audio, in images, right? In tables even. However, most of the data comes in the form of an unstructured data. So let's say this workshop has a total of 30 attendees, 10 of which are aged between 18 to 24. So these are basically just texts describing what the participants are or attendees are for this workshop. So the next form of data would be a semi-structured data. So a semi-structured data is to its name, right? It is structured in a manner where it's organized in a sense. However, we still need to do something else. We still need to take that step further for us to be able to generate insights and analyze the data that for what we can get out of it. So lastly, we have a structured data. So now structured data would be coming most of the time in a form of a table where you can easily see something like the name, the age range, and the degree. And again, these information relate back to the unstructured data here. All right. So where is data found? Where do we see data? Data can be found on a busy street, in fact. So an example of which is how many people have visited this street, or how many shops are there in this street, how many vehicles pass by at a period of, like, let's say in the evening, around 6 in the evening up until 9 in the evening, right? How many flyers are being passed around in the street? How many billboards, how many markers are being displayed? How many advertisements are being displayed? How many advertisements for a certain company are being shown in the street? So just a simple example, right? A busy street, it's full of data. Next would be definitely manufacturing machines, right? So whenever like a product is created, the machines would count the volume of how many products were created in a certain period of time. They would also record data when there were issues within the machine. And then they would also look at data where the processed products from this line of the machine, and then when it goes to the next line of machines, they would know how many were wasted, how many were has defects and such. Data can even be found definitely in social media. So I'm not sure if you've heard about some controversies about the spying and of TikTok and even of Facebook and the rest of the social media applications. There's lots of data involved in this one. So you yourself, ourselves, whenever we use social media, whenever we watch a video on YouTube, on send images on Snapchat, scroll through Facebook, watch videos on TikTok, all of that is recorded, and that is actually usable data for the big tech companies, even in our homes. So you might wonder what why is there data in our homes? So we're using electricity definitely in our homes, right? So whenever like a bill comes in, um, you would know how many kilowatts per hour you consume for that certain month. That in itself is a data point. Now, especially for smart homes, like we have here a TV that is a smart TV. We have microwaves, refrigerators, garages that can be customized to be a part of the smart home. Our watch, our cameras, our CCTV cameras, and all of those things. Data can be found in our homes as well, especially in grocery stores. So this is very important even um, to to big companies such as Procter and Gamble. So I had the pleasure of working with data using image recognition in grocery stores. So what they do actually is they look at the shelves and look at how many products were being placed on the shelf. So there are certain KPIs that are being generated just by looking at the grocery stores. And you would even notice sometimes the security in grocery stores, they would have this sort of like a counter. That in itself is a form of data. How many people came in that store at that particular day, even to that particular hour. All right. So basically, what I'm trying to say is that data is everywhere. Okay. So who uses data and why is it important? So let's take a look at these few examples here. So let's start with this scientist here. Okay. So a scientist uses data to study whatever field they are in. So let's say there is a geologist who wants to look at certain tectonic plate shifts that happen through the course of the Earth's entire history. So millions of years. How did Pangea split apart? How did Africa, Europe, South America, North America were formed based on those tectonic shifts, based on earthquakes, etc. Right? Even a chemist, we need to use data to figure out what the composition should be for a certain reagent or um, a certain mixture so that we can come up with like a good ratio for gold, for example, or for certain products like toothpaste or laundry detergents, right? Politicians use data. So politicians, when they run for office, they would definitely run campaigns based on existing data from previous elections. Okay, so they would go to certain counties, they would go to certain states, depending on where they could get the most votes, probably, or even get and convert those voters into their side. And even when they are in office, right, they would use that data from the different departments to make decisions. Businessmen, so the people in the field of manufacturing, um, in stocks, so they use data every day in order for their work to progress. Otherwise, if there's no data, then they sort of become blind to what they're doing. They can't really make the good decisions for their company. Even doctors use data. So when they try to talk to you about what your health condition is, so the healthcare system now, in fact, it's designed in a way where a database of your historical illnesses are already stored. So they can easily look up, okay, this patient came in with with an ailment that is described like so. Let's take a look at their historical record, and okay, there it probably is related to an incident that happened like 5 years ago. All right. And lastly, everyone here, each and every one of us use data. So when we commute, when we go to our work, we know when the rush hour is. So we would strategize in that sense that okay, if rush hour happens at around 7 a.m. to 9 a.m., or like five in the afternoon until 7 in the evening, right? We would try to strategize when we should be traveling to our work, even to out of town. Okay, so data is was used to transform our worldview even. So a picture on your left shows a map from the 1600s, where they plotted the world as a flat world even. Okay? And with enough data that we've gathered through expeditions by Columbus, by Magellan, we figured out that hey, maybe the world is not actually flat. We were able to circumnavigate from one point to the westward, and going back to the same point, and then likewise going east and moving back to the same point as well. Another worldview that was changed is one of the most famous ones is the heliocentric theory, where or geocent from the geocentric to a heliocentric theory, where people before believed that Earth was in fact the center of the universe, that the planets, the stars, the sun even was revolving around the Earth. It was merely just these heavenly bodies that shifted within our point of views. However, with enough data, again, now we know that the Earth actually wobbles and spins around at a certain rate and revolves around the sun for us to create like concepts of time and dates. All right. And lastly, this is the most recent example, even. I believe this has shifted our entire worldview in the most recent era. So before, when we try to look for answers, like let's say, how do I fix my broken microwave? I hop on to Google. Even before Google, there was Yahoo, and then but now again, like Google revolutionized the search engines, and then just recently, OpenAI shared the third iteration of their chat GPT, and questions like these can now be answered. As a matter of a fact, chat GPT was able to pass an exam in Stanford for a medical finals exam. So data was used to create the chat GPT that as we know it today. And business data is being used in businesses as well, definitely. So again, I mentioned earlier for Procter and Gamble, they use image recognition to look at stores and see how much products are being placed on the shelves, right? Netflix uses data for them to propel themselves to where they are right now. Tesla uses data from different parts of their cars in order for the machine to be self-driven. And even government agencies such as the FBI, Behavioral Science Unit, even if you guys are fans of documentaries, so they actually use data from existing murder cases and created a profile for those murder cases, and eventually now we know them as serial killers. So data was actually used for the FBI, for our society to know that, hey, in fact, there are certain archetypes for serial killers. And the main point here is that organizations make it their core value to make to use data to make data-driven decisions. Now, what are the types of data analysis that are present in our world today? So I mentioned earlier what is data, where can data be found, who uses data, right? But how do we actually use data in order to derive those meaningful and actionable insights? So the first step of data analysis. So let me just also share the x-axis here is the complexity. So of course, the farther you get, the harder it is to do. And on the y-axis, you have the value. And again, the farther you get from the from this spectrum, from this line here, from this axis, there's more value to the business. So let's take a look at these four different types of data analysis. So the first one is descriptive. So this is based on live data that's telling us what's happening in the real time. So from its word, right, we have data, we were able to process that data, and now that it has been processed, it has been transformed, we can definitely derive insights that tells us what's happening in real time. So descriptive analytics is accurate and handy, especially for operations. So let's say we have a sales team that wants to deploy certain items based on their month-on-month deployment of products, right? So let's say we are in the middle of the month right now. What the sales team can do is they can look at data from the previous month. Okay, we sold around X amount of goods, and then today we have sold this amount of goods. So probably we have a little bit more to sell, a little bit more to deploy into the stores based on that data from the past month. Another type of analysis you could do is even look back to the previous year. All right. How much did I deploy? How much did I sell? How many did I deploy from the year of 2022 for February? Right. So we can extrapolate. We can determine in real time that okay, this might be the strategy that I need to do. And lastly, it's very easy to visualize since, again, you are describing your data, be that in charts, in trends, in columns, right? So that's what descriptive analytics is. So the next one is diagnostic. So diagnostic would mean that there would be sort of like a root cause analysis involved. Okay? So from describing your data, we now move on to asking questions, right? Like, why is this data happening like so? Or why is this description of my data true? How did this happen? Or why even, right? So it helps troubleshoot issues that come in your organization based on your data. So you can take a look at this one, like having a step further from merely describing your data to actually answering questions as to why things are happening. All right. So that's the second type of data analysis. So the third one is predictive analysis. So let's say you started with your data that describes what's happening in real time. Okay, I want to solve a problem that came about from the data that I found. So I had certain insights that, okay, this store is actually selling less than what I expected from the previous data that I have. From last month, let's say it sold like 1,000 products, and then for this month, it's only selling for 100, even it's already mid-month. All right. So we can describe that data specifically. So let's proceed to ask why that's happening. Okay. So probably you add in more data points to your analysis, and then you would see that, hey, for this store, this is the supplier that we provided for that store, and that supplier has limited amount of products for this month. So we haven't really replenished this supplier with enough products for that store to have inventory. All right. So now we have solved, or we have sort of like took a look at what the root cause for that problem really is. Now we want to predict what's likely going to happen in the next month. Okay, so let's say we have this existing product now. We know why it happened. So let's, again, based on historical data, we will assume a static business models and plans as well. So with predictive analysis using AI, we can extrapolate, okay, how can we even deliver to this store that is problematic. So predictive analysis helps business to automate those decisions using algorithms. All right. So again, the key word here is to automate those decisions using algorithms. So you have a data, you're able to describe your data. From your data, you're able to answer questions from your business need based on your descriptive data, and you want data analysis to proceed with predicting what's going to happen in the future. And again, it's being automated using certain algorithms. And the last and the most complex type of data analysis, and the one that gives the best value to us, is prescriptive. Now, this is the future, actually. In all organizations that I've worked in, they want their data analytics team to reach a certain maturity so that they can go to this point number 4, which is the prescriptive type. Okay? So imagine you're able to automate your decisions, right? Based on certain algorithms. So you're able to predict something. So let's say what is likely to happen next month based on my data this month, based on my data a year ago, based on my data last month, last 2 months, for the past 3 months. Okay, I can sort of predict based on my descriptive to diagnostic. Now I'm able to predict it. However, the next step is to actually prescribe. So your data analysis, your machine learning, your AI will now tell you, okay, this is what you need to do. So is it that amazing, right? From having to describe your data, simply describing your data in graphs, in pie charts, in trends, to diagnosing your data, what the problem, where the problem came from, what the problem is, why are things happening, to the point of predicting your actions based on automated algorithms. But now you want your data to prescribe you actions. So for me, that is extremely fascinating. And I can actually share an example from the place that from one of the places that I worked in. So we ran through these three stages here: descriptive, diagnostic, and predictive. And then based on those data that we had, we tried to look at shopper shopper data, or we called it the shopper basket. So what we did is we took a look at what people were buying when they buy certain products on on the store. Okay. So one of the analysis that we did is that, okay, so if they buy, let's say like a shampoo, they would also buy chips. All right. So, and they would buy cookies or some other type of junk food, if you would say. All right. So what we noticed, then the next step that we did, okay, they were buying products from a certain brand. However, one of the products that they bought is not from that brand. Okay? So we asked ourselves, why is that the case? So you are that person, or a lot of them, actually, a lot of the data points that we had, they were very loyal shoppers. So they bought items from that certain brand, from that certain company. However, in one of those products, they didn't. So we took a look at what those products are. So we took a look at what the commonality is. And we found out that the product that they were buying, there was no SKU that was being sold by that company that we were analyzing the data on. Okay? So we told them, okay, this is what our AI learned, that your competitor is selling a certain SKU, a certain product that you don't have. So would you like to try creating this type of SKU? And the results were fascinating. so so they converted. So when people went to the store and they saw that, oh, there is actually a product from this company, from this brand, that is something like this, so I don't need to buy this product anymore. So within 6 months, we converted around 75% of the shoppers to be extremely brand loyal, just because of this prescriptive analytics. So I hope you guys share my fascination as to what data analysis is. And it like the bottom line is to use advanced algorithms to test potential outcomes of each decisions and recommends the best course of action. So again, let's just try to review, right? The farther you go from the y-axis, the more value it delivers. And the farther you go from the x-axis, the more complex it gets as well. So what do you call it? These types, these type 3 and type 4, predictive and prescriptive, these are what data scientists do, in fact. Okay? So next is data and decision making. So data science, this is the data science process in a nutshell. So it starts here above. It starts with a collection of your data. And again, data can come from any kind of form, right? Be that in audio, video, text, Excel files, comma delimited files, PDFs, websites, application data. So this is that step. We need to collect the data. We need to know where to get the data. After we get the data, we need to clean it up because we can't necessarily do our analysis for like, let's say we have like 1,000 episodes of a video podcast that we're trying to watch. We want to see the patterns on where people click on a button whenever there's an ad that is being placed. So there's an ad placement for that video podcast. When would people click? At what point would they click? And then there's thousands of videos out there, right? So we need to clean it up. We need to have it in a manner where we can start our analysis. So this is a very important step. And in these two steps, usually who does these are your data engineers. Along with the data engineers, the data analysts will come in as well to do your data cleaning and explore your analysis. So data analysts actually do the work for these two steps here, the descriptive part and also to some extent the diagnostic part. All right. So the next step again is to explore what questions the data could possibly answer. All right. So usually the business would have like, okay, I will give you data. I want you guys to generate insights based on this data. I have a problem. This is my problem. Can you try to solve it using that data? So the data analysts come in this step, right? However, again, there is a third and fourth type of data analysis, which is your predictive and your prescriptive. So this is where machine learning engineers come in. Okay? So they will build data models based on your data that was cleaned up by the data engineers, and also working on top of the analysis that the data analysts created. All right, so they will build their data models based on advanced algorithms, statistical methods, and such. All right, and once they have perfected that model, so it takes time to build actually. It's not just like, okay, I have data, I send that data into the model, and then model generate prescriptive analytics for me. So it's not that simple. So a lot of times machine learning engineers will try to figure out what the best type of machine learning model they should use. All right. And what one thing as well is that machine learning, since we're using AI here, it's not necessarily accurate. So that's one thing that I want to point out. So the challenge for machine learning engineers is to know and to understand and to design a model that is extremely accurate in the scenario that they want to predict. Okay? So once that model has been built, it has been trained successfully, it will now be deployed. And then that is where your predictive and your prescriptive analytics come in. Okay? And you would notice here down below, data scientists can overlap in all of these fields. Okay? So that's the important thing to note. Let's say you're a data engineer, you are good at managing databases, but you can then also be good at visualizing your data. You're good at analyzing your data. What much more is that you're able to apply machine learning in the data that was generated. And that makes you essentially a data scientist. So you're working end to end and acquiring the hats of all of these three different roles. All right. So what are the benefits of data science? So there are two main points really that I want to share. So the first is to make sound strategies from existing data points. Because again, we have data, we have unstructured data, or even like random. Like random is like the generic word. So we have random data that was being shared to us. From that data, we need to process it. And the end goal is to do these two things, okay? To make sound strategies and to make data-driven decisions. So first, you need to strategize. How would the business approach this problem, right? So there would be, of course, there would be different sort of strategies to be taken in place. So my next slide actually um, describes what those strategies would be. So I'll go through these in a bit. But for now, you will need to make those strategies first. And from those strategies, from those different permutations of your strategies, you need to make decisions that are grounded in data. So that's what they call the data-driven decisions. And again, I mentioned earlier, I'm sure a lot of us here have been experienced in working in different fields as well. One thing that you would notice in the recent years, they make it their core tenant, their core value to make data-driven decisions. So data science makes valuable insights. It creates continuous growth. It improves program outcomes from your strategies. It optimizes your operations, like I mentioned earlier. If you have something that is prescriptive, you would be able to take action and optimize the actions of your operation team. Okay? It predicts future trends like the prescriptive analytics. And then lastly, it creates actionable insights. So this is the main point of everything that is described here in the data science process. Sorry. So that is the main point. It will create actionable insights. All right. So one thing that you would also hear a lot when when you're in the field is the term business intelligence. So again, I showed you earlier what the data science life cycle is. Business intelligence just means that um, your business or the company that you're working for, or if you're an entrepreneur, um your intelligence sort of like what you should do, what you should be doing, what your action should be would be based on data. That's why your data analysis, your data analytics part is called business intelligence as well. So these are just sample strategies that are being derived or data is being applied into. So for example, a SWOT analysis, a strength, weaknesses, opportunities, and threats, a cost benefit analysis where you get the net present value and create a cost benefit ratio. So what are the benefits against the cost? And then there's also decision trees as well. So there's a situation X. I want to strategize what I can do. So I have decisions, and then leading to outcomes, and also taking into account uncertain decisions. All right. So let's show real world examples of where data science has been applied. So Netflix is one of the best examples. So Netflix uses data to create new blockbuster hit series. So I'm not sure if everyone has heard of the Witcher series, but actually Netflix created that series based on certain data points, especially with Game of Thrones. So there was a need for this low fantasy medieval setting kind of a series. So Netflix created some other series as well, but an example of which is The Witcher. So Google uses people analytics specifically to create a better workplace. So they created this Google Workplace, right? And there's lots of lots of companies that are now adopting Google Workspace. So not only did they integrate that data into their product, which is the Google Workspace, they also created a huge campus in Silicon Valley that makes it very like a very nice place to work in. So next is Coca-Cola. So they serve customers with ads more efficiently. So they use data, be that out of home advertisements or flyers or billboards, etc. So depending on what the market is, where they are located, they would customize their ads to be more efficient. And again, they use data for that. Okay. So DBS, in the banking industry, they harness AI and analytics to serve customers better. So if you guys, me personally, I have difficulties dealing with banks whenever I make transactions. However, DBS harnessed AI and analytics to serve customers in a manner where certain issues, certain questions can be solved within a matter of minutes. And lastly, Uber. Uber provides faster and more efficient ride with the data, existing data that they have, and external sources as well. Like I don't want to name their names, but I'm sure they're also getting data from external factors. So they use those data points to provide a faster and more efficient ride. All right. So now I'm down to my last slide, actually. So what is the future of data science? And specifically, what does the future look like for you? You that are attending this workshop right now. Let's say you want to work as a data scientist. I'd like to tell you that data scientists are very high in demand. Okay. If you try to search job postings in the internet, you would see data scientists everywhere. And again, this isn't even limited to data scientists. If you could remember my slide earlier, a data scientist is very versatile, right? They can be data engineers. They can have a hat of a data engineer. They can have a hat of a data analyst. And lastly, they can also have that hat of a machine learning expert. All right. So an average of around 100,000 dollars salary is what is waiting for you as a data analyst. So next is it's a defined scope. So since data is everywhere, you can be assured that the scope is defined and data scientist roles for all types of organizations. Okay, so there's lots of data lying around, and your scope as a data analyst is extremely defined, and it's based on that life cycle that I shared earlier. So if you want to work in a structured in a structured manner, if you want your work to be defined, especially the scope, because sometimes you're able to when we're working, like the scope gets out of hand, right? Like, oh, that's not part of the scope that I need to analyze, etc., etc. So they for data scientists, the scope is actually defined. So the next here is the creation of more jobs, right? With the advent of advancing technologies, not only will data scientists evolve in their careers, right? I mentioned Chat GPT earlier. But in turn, this will create new jobs that were previously unheard of. So there are certain use cases, especially now that, again, technology is really advancing at a very fast rate, at even to some extent, even at an alarming rate, even. But this is not alarming for me. In fact, it's very fascinating and very exciting that there are lots of possibilities to create more jobs, to create more insights, to answer new questions that we didn't even think about before. All right. So the next one is data. Data is everywhere. Again, with the defined scope that I mentioned earlier, practically every company needs a data scientist. So where there's data, data scientists should be there as well. All right. And lastly, you're able to shape the future of your company or the company that you're working for. Okay. So data scientists would prescribe, predict how businesses operate based on the advanced analytics that are generated along the process. So you wouldn't feel like you don't have an impact in the organization. In fact, you are their business intelligence, right? You are the reason why they would take such and such action. Okay? So based on your data. So that is all for my talk, and I would like to endorse this data data science course brought to you by Skillspire. If you could scan this QR code just to see what the course content is, feel free to do so. I will flash it for a bit. And again, this is just an introductory session of what data is, why it's important, and what the future is for data science. However, when you go to this course by Skillspire, you will learn more about the specifics of what a data scientist would be. Okay? And yeah, that's it. Aldrich.
All right. Thank you so much, Jude. Let me just share something. So, guys, okay. So we're here to help again, and yeah. Wait, let me check. I would like to announce to everyone that we're going to send you emails of the recording if you wish to watch it again. Okay. And I'd love to ask a favor to every one of you. Please wait, let me share my screen. Uh-huh. So a favor, please scan the code. Your feedback is important to us, and we would like to use it to make future workshops even better. So this is a survey form. You can answer it for just like maybe 2 minutes. Okay, 2 minutes max. And it's just gonna take very quick of your time. So thank you so much in advance, guys. And yeah, we'll keep you posted on our next few workshops. So just don't forget to be subscribed in our email list. Okay. So yeah, I hope you've learned a lot from this workshop. And that's it. Thank you so much for attending. And we'll see you guys soon. Thank you so much, Jude. Let's all thank our host, Jude Valiente. Maybe you could chat in the chat box, guys. Or, unmute yourself and say thank you to our host, Mr. Jude Valiente. Alrighty. So thank you so much, everyone, and see you in our next workshops. Bye.
Thanks everyone. Have a good day. Bye bye.